First, I want to thank you, Peter, for being with us and taking from your time to for this episode. I appreciate that.
Oh, thank you, Miguel. I really appreciate this opportunity. I love
Thank
to
you.
be able to share stuff that I've been doing.
Thank you.
It's fun to me.
Now, something nice that we want to share here will be all your work progress with AMRs
Hmm.
and all the things that you've been doing with the drones and all the process. So first, you can give us an introduction of your background work so we can know you better.
Okay. Yeah, well, I mean, most of that I put in the slides. Um, so I guess if I could just kind of jump and talk to them.
Yeah,
Um,
you're
I'll
ready.
give you, yeah, I'll go ahead and give you my educational background and the things that I've worked on in the past.
Yeah,
Uh,
that's great. When you're ready.
okay, so this is on DIY autonomous robot projects.
Great.
And I have my email on the bottom, which is just ZenoRobotics@gmail.com. And I think what I'll make available is it actually a file or something where I have a lot of links that I put together for the drone project.
Great.
Yeah, and plus the my YouTube. I have a YouTube channel. Right now I just have my TankBot on there, but that'll be changing very soon. And so my educational background, you see, is mostly in electrical engineering, computer science, and engineering. So it's the good thing is it's it's a broad, it's an encompassing background to say the least, because with anything you really need to know your computer science. Electrical engineering very helpful if you want to be able to get into the circuitry and understand some of the basic concepts of communications and such. And I actually worked in industry for about 30 years. I worked for the government. I worked for the Navy where I was working on some aircraft sensor fusion with light radars. And I worked with Raytheon, Lockheed Martin, MIT, Lincoln Labs, and
Big name.
Synopsys. Yeah,
Yeah.
big name companies. And then while I was working on my PhD and then a postdoc, I taught quite a few labs of microcontrollers and also in FPGA design. And like at Synopsys, we did a lot of checking designs that were going to go to ASICs that were typically in FPGAs. So ZenoRobotics, I established that at the end of 2019. And so I started out, I wanted to give in the robotics, teaching into robotics, but I wanted to give the basics that are required, at least the foundation. And so the Arduino microcontroller platform, which uses an Atmel microcontroller, was easy. At least if you have a C++ background, yeah, then and they make it very easy because there's so many libraries. It's just like it's so easy to write to a digital I/O or set it to input output, things like that. And that's actually part of my TankBot. It started as the interface to the motor controllers and stuff like that.
Any experience with Python or just mostly
Yes.
you have been working with C++? Because
Yeah.
I know
So
C++ and C and Python are the mostly languages using.
yeah, Python is huge, but you still run into a lot of C++, especially in ROS, but mostly Python. And so I picked up Python pretty quickly. It wasn't that bad. Although I see some advanced stuff that I started working with, and I'm like, I didn't know you could do that. So there are some really intricate things that you can do.
Yeah.
There. Yeah, so the intro course was to build the foundations of knowledge, like I was saying, because I wanted to be able to get into teaching the robotics. And so essentially, it's all about your agent, which is like your microcontroller, or whatever processor you're using, maybe a Raspberry Pi, And so you have sensors that sense the world. And so the agent takes those, say, LiDAR or images or whatever, and does some sort of perception. It has some sort of goal that it wants to achieve, and it has a current state, next state figuring. So there's a lot of different types of agents you can have. And then you have effectors that take action on the environment based on its decision making. And essentially, that is how the human brain works, similarly.
Yeah. So, I see the environment, and that's one important thing there to take.
Exactly. And so, yeah, it can be very specific. So robots typically are very specifically designed to their environment and to their task. So, yeah, so I was offering online. I wanted to offer online now because of the COVID. So the COVID kind of threw a monkey wrench in my head. Yeah. So that's what I'm streaming for, is to be able to go and do some online courses, but I'm also juggling a bunch of other things.
Yeah, the pandemic took bad things, but good things, because now people is looking more robotics because all the things about the pandemic. Like, yeah,
right. It's really democratizing.
Yeah. Now they're making a faster implementation.
Yes. So it's faster than I have to get stuff out there. Because everybody else is getting stuff out there.
Yeah.
Yeah, and also provide prototype research and development for companies that are starting up. And I also would like to create my own product at some time. I have many ideas. So the big thing, so COVID-19 became an issue, but another thing also in 2020 is I heard about this DARPA subterranean challenge that I wish I had known about like a year or two before. It was something that was going to go through, so four different type of competitions, but 3 different type of environments. So they went through a tunnel environment first, with autonomous mobile robots, and you have to be able to show that your robots are able to do certain things to be able to qualify. And so you qualify for the tunnel environment, and the next thing was the urban environment, which they had. I watched that on YouTube. That was like so cool. I was like glued to the computer. And then the cave environment, I was getting ready for that. And then that was pulled away from the systems. They did the virtual one, which was all software, but I was into the systems. So actually starting, I believe, next week is the final, which incorporates all 3 of these in a mega cavern. I think it's in Louisville, Kentucky. So I would definitely catch that. That should be really interesting.
And how you knew about the DARPA project?
I just ran across it, and I'm like, oh wow,
Yeah, and this is the one that take all these projects in the government and
yes,
yeah.
They had a grand challenge some time ago.
Yeah.
Going through the desert, driving a car.
Yeah, I see a few projects for space that are coming from there, from DARPA.
Yeah, so I was hoping they'd have another one like this soon, but I didn't see anything in the horizon. I was thinking about throwing together my own small scale one to get more people to come in. The thing is that to be able to go through these environments, you needed 3D LiDAR, you needed some expensive communication equipment, because in these environments, communication does not travel far. They get absorbed by the walls. And so you have to drop breadcrumb network nodes. And so it's a really expensive task. A lot of the people got money from DARPA to be able to just play the game. But so this one is a drone. This is from CMU. I actually worked with these robots, and you'll see them in the final this coming week. So this was a student-made one that's actually, it's pretty cool. So it has a 3D LiDAR up here, and the thing sounds like a major leaf blower, and it kind of is, because it's heavy, but it's got to be able to lift and travel fast and search and map. So it's the big thing is to find artifacts, and artifacts is like something that looks like a person, a cell phone, rope, things like that. And so the more you find in short amount of time, that's how you win. And so there are quite a few spots.
Yeah, that's the one from
Boston Dynamics.
Yeah, Dynamics. Yeah.
Yeah. So I mean, when it comes to stairs, it's really hard to get a robot up and down stairs, but these things do it so easily. And that's like, I mean, they're showing the terrain of this, so this is a pretty rough terrain. A Spot would really do it.
They're doing the great work there. Like,
yeah,
they're pretty advanced with all these things.
Yeah, they've got a lot of government money.
Yeah.
Sponsorship.
Yeah, good support.
Yeah. So yeah, so
yeah.
So this is where I got going. So the first thing I did was the TankBot, and so that's the one on the left. And so I just got this chassis, and I of a tank, and then I built the different shelving to be able to put the Raspberry Pi on there, and also I have an Arduino Mega on there. I have a controller board in the back for DM25, I believe it is, for the motors, and you can program speeds and stuff like that. And then 2D LiDAR on top, camera, webcam, and I'll show a video of that in action. And the latest thing is the drone, this quadcopter. And so I saw online that they had, build your own quadcopter, RPi based quadcopter, which is really cool, but they just kind of show you how to connect up the RPi, and then you're kind of left on your own to know what to do after that. But the big thing about getting the RPi on there is to go to off-board mode, and you want to go to off-board mode for it to be autonomous. So it'll go through its object recognition, it'll go through its SLAM algorithm. All of that's going to be done on the Raspberry Pi or whatever processor or a couple processors you may need to be able to accomplish that. And so that's the big thing that I'm right now trying to get to the off-board mode, which I would have achieved last night, I'm pretty sure, if my GPS was working and I could get enough satellites lined up in a small field. Okay, so this is just a quick video showing the TankBot. Yes. So it's doing a Hector map with the 2D LiDAR. This is just showing, this is a teleop, and I also,
can you open that video, like, or is only that size?
Oh, on YouTube? Oh.
Yeah, like, be wider so people can see, like, and can explain. But it's okay if you cannot do it.
Yeah, I don't see that up.
No, it's okay. No, you can continue.
But I'll be giving links to all this.
Yeah, they can see it. Yeah.
So you can see on the screen through the Wi-Fi connection, I'm able to see when I put RViz up, and you can see the vector of it moving, of the robot moving. I had used, see the white pads? I had used the sonar sensors, but then I figured out how to sample certain angles off of the LiDAR to be able to figure out if there's an object in the way. So I no longer needed that, which was really cool. And so then also I'm displaying the camera, what the camera's outputting. These are the vectors of it moving. And yeah, so that's the Hector SLAM. Yeah. So I actually had gotten the CMU Ubiquity Robots. I actually used their OS image, Ubuntu OS image. It was very friendly. And I think it was a 16.04. And I'm still using that on that one. On the drone, I went to the 20.04. And so some things got better, some things broke.
Yeah, Ubuntu is a great platform for robotics.
Yeah. So, yeah, so that's about that. So the TankBot, so it's goes by a couple names. So you have autonomous mobile robots, the MR, and also the unmanned ground vehicle, as opposed to the unmanned air vehicle, as opposed to, there's a lot of different acronyms. And the hardware on there is the Arduino Mega, which I'm using. I actually use ROS serial to make a node on the ROS on the Raspberry Pi, which was running ROS. And that was there. I had issues with the motor controller, which were huge because.
What kind of issues?
So I finally got the O-scope out, and I could see that it was causing really spikes of high frequency due to the motors, even though they have caps on it, and also the controller has caps. It would cause the Raspberry Pi ROS to just freeze up, that interface to USB to just freeze up, and so it would just go bonkers. Sometimes it would just spin around in circles. So I put in another cap, and it seemed to have fixed that problem.
Do you have experience with the Raspberry Pi? But there's only any other one that you've been working beside Arduino is another one. But we know everyone that Raspberry Pi is like the main one everyone is looking for. But there's other ones out there. Do you have experience with any other one? I
have the Jetson TX1, which I may use when it comes to doing more. I mean, that is not any better, I think, than the Raspberry Pi, except that it has the, what do you call it? The processors for the video processors. Yeah, so they have those, and so they will be able to do a lot of quick processing on images to be able to do that kind of deal. So GPU, thank you, Harry.
Yeah.
That escaped me. I actually did programming on it before. I actually did right down to figuring out the algorithms to minimize memory movement. I mean, it's quite a science too, but they've kind of automated a lot of that. And so that's just a link to my YouTube videos, which I can give.
The TankBot, yeah. It's a nice project.
Yeah, so software has C, C++ code on the Arduino, Ubuntu OS, and ROS on our Pi, ROS serial for the ROS node, so I could, as a subscriber and publisher running, I actually wrote code for the Arduino in C to be able to send and get data through the ROS node, which then did it in Python. So that was interesting.
Nice.
Yeah. So that worked out fine because they were divided up anyway. And then
is there something that you can show us about that, or not? You have something?
Actually, I did show about my debugging it.
Under a video on YouTube?
Yeah, on YouTube.
Oh, good. Yeah. Good. Well, we can provide that link. Nice.
Yep.
What else?
So the Quadcopter came next, which was huge.
Nice. I like that one.
I knew absolutely nothing about quadcopters, except I bought a Holy Stone, a little thing with a camera, and it's like you got it flying, and it's like, this is really cool. But I get bored after about 10 minutes. It's like, okay, well, that was really great. But I wanted to make something that was autonomous, something that I could give it smarts. And to me, that's way more exciting than just flying it, but that's me. Mm-hmm. So I didn't know anything about, these, opposites have to be spinning different ways, and then the blades have to be going a certain way, depending on that spin, to get you to lift, the Bernoulli effect, and all that stuff. So this drone dojo is where I had gotten my links for parts and videos. It was actually a very good place to leap off from, except they were using 18.04 at the time, and that link then went to 21.04, but I was able to get down to 20.04. And just a lot of things break that you're using an ARM processor with a newer version Ubuntu, and then also ROS changed because no longer was one version of ROS available anymore. they don't need Noetic after 18.04. So I mean, when it comes to Ubuntu, there's always an issue, always an issue. But you can do a lot of things. And,
Yeah,
so
you have to go to the long time version, maybe like something
Yeah.
where they do updates. It's like that.
Yes. Yeah, and thank goodness for Googling, and people actually put questions out that people seem to yell at them like, you're asking such a stupid question. I'm thinking, thank goodness for asking a stupid question, because I had the same stupid question. Be brave. So this is the electronic system components, pretty much of the drone, except this shows one ESC, but mine came with 4 separate, which really doesn't matter.
Nice.
Yeah, so I'm able to just tack one under each of the arms. So essentially you get your receiver, you get your transmitter, receiver, and that puts it into pulses that this PPM sum receiver, although I don't know if it's really summing, I think it's probably doing time division multiplexing of these PPM signals. And so then that's how the Pixhawk takes it, and then it goes out in pulse width modulation. And that pulse width modulation then gets converted into voltage levels, and whether it should reverse it or go forward, how much, how fast. So a motor is really how much voltage it gets in electricity. And so then you have your LiDAR, not your LiDAR, your GPS that connects up pretty easily, and so you have telemetry. You have a telemetry. I know this is hard to see. I actually blew it up a little bit for this side.
Yeah, nice. Can you zoom more? Zoom a little bit more. So, yeah.
Oops.
No, don't worry. It's okay.
Yeah.
Yeah, that's okay. That's okay.
Yeah. It really should be zoomed, twice this, but anyway, so each one of these main output channels go to control one of the boards, and they have to be numbered just right. So motor 1, motor 2, motor 3, and then which ones are 1 and 2, those are the opposites. And so then you have a switch to be able to, a kill switch, which does not work on mine, so that doesn't help. I have to stick my hand in blades, try to unpower it, and disconnect the battery. I want to put a switch on that. So you have telemetry, receiver, a buzzer, a bunch of lights, and these lights, the way they blink and stuff, have importance to them. You can figure out what's going on, but so this is the receiver and some other stuff. I use a laptop, and I just plug in the telemetry into that. Okay, so the required parts for any Raspberry Pi would be the Raspberry Pi 4 model. So I was actually using, I wanted to go ahead and use 64-bit, so I actually got the 8 gigabyte RAM.
Yeah, that is better. Because
yeah, I think so.
More RAM.
The thing's fast. The thing is really good. And even for 20.04, which they call kind of like the Windows of Ubuntu, but that's fine. It's awesome. So the only thing is, like, I wanted to get a QGround Control working, but they don't have any binaries out there right now. Everything is like for AMD and whatever, but so I have to figure out how to go through and build it and create my own one, so I can actually write, just for debugging, to generate the right executable. So you have RC controller, frame, props, battery. So you want LiPo batteries, and you're supposed to have a fireproof case. And I really, before I burn down someplace sometime, I really should do that. Velcro straps and such. So here I am set up outside it initially, just trying to get things to work. And this is this is before I put the Raspberry Pi on, but it has everything else minus the props. So like a few people said, yeah, don't be putting props on the inside. And Oh yeah, the required lift after weighing all the components. So I actually saw someone did on YouTube. They put up together a test to be able to figure out how this one exact motor at various RPMs, how much force it lifts. And although it was kind of flawed because the coefficient, the way it was like a wooden dowel, and it was through a hole and it was connected to a weight that was on a scale. But of course, the dynamic and static frictional coefficient of wood against wood, I mean, they should have at least kind of boiled it up or something. But anyway, that gave me an idea that the lift would be fine from that. And I think I did put the stats in there. If not, I think I have it further on. So this is just showing you a quick flight. I was really preoccupied with other things and not taking videos. But that was one of the autonomous flights. And the autonomous was easy to do. You don't have to do autonomous through Raspberry Pi. You can do, and I'll cover that in a second. So I'll just hold off on that.
No, it's okay.
Okay, so yeah, so I'm using Ubuntu 20.04. Mavros, you don't necessarily need to use Mavros. You can use Mavlink or straight Mavlink, I guess. And there's also, I'm using PX4, but you can use ArduPilot. And ArduPilot, you can use PX4 and ArduPilot with what they call a mission planner, which is a comparable version of QGround Control. And I think that probably has more following, more information you find. It just seems simpler. But I had started at CMU working with QGround Control and learning the Mavros and PX4, so I just thought I'd go the harder route anyway. See how that went.
Yeah, I want to say something about the questions. Guys, at the end of the presentation, we're going to take all the questions you want. So you can start writing on those questions and we're going to answer each one of them. Okay? Thank you. Okay.
Okay. Yeah, so the PX4 is actually two parts. So it's the flight stack. So it's taking a lot of input from various sensors, primarily like the IMU, which was, kind of going back to the Arduino, the one thing that I had is a 6050 MPU board. And so you have accelerometers and gyroscopes on there, and you could play with it and you could do programs and watch the output. You could watch the drift and stuff like that. And so that was like that gave me the background to know that, oh, well, that's the kind of things that the sensors that are being used, like in the Pixhawk and other controllers. And then there's also a middleware. So you're communicating, you can pick which firmware that best and upload it to your Pixhawk in both of the QGround and the other one, as to whether it's a 4-arm or 8-arm, or depending on what the platform is. If it's a fixed wing, all that stuff, you can pre-select all that, and it'll configure how the Pixhawk controls servos and such, like the way you connect things up. So, okay, so this is where I was going to talk about, you can do autonomous without Pixhawk through a GUI. You can, but this is fixed, okay? So this is not, well, you can't really deviate from this. You set up a flight plan of where you take off and you plug in your waypoints just graphically, and you put what the speed is and what altitude they are. And then you upload it, and then you just kind of hit play, and then it flies autonomously. And And so, and you can also add a geofence to it, so you want to make sure it doesn't go rogue and suddenly just keeps going. It'll hit this geofence within certain, it'll remember the locations of that to either stay in or stay out of certain geofences. So that's kind of a cool thing. And also QGround Control, you can use it to set up your RC transmitter, which was great. Yeah, because I didn't know that off the hook, and then it was like, oh, well, this only works with an Android app. And it's like, well, I don't have an Android phone, and so, but then I found out that I could do it through QGround Control, and I believe you can also through the mission planner. And also, you also set up
calibration.
Yes, so you set up your sensors. You have to do all of this and make sure you do it about as accurate as you can. I mean, with my Holy Stone, not so much. The thing really is pretty durable. But I use a board and make sure everything's like right angle and stuff like that. So that was very helpful. And so I also do a lot of simulation first, and you could do software in the loop, which this shows, or hardware in the loop, where you can actually take your Pixhawk, plug it in, and connect that up to QGround Control. Typically, Gazebo takes over the physics, and it'll give it GPS coordinates, and so it'll give you the things that are lacking, so you can do your simulation. And so there's a way of going about this. PX4. So I have links to all this stuff.
Yeah, we can share those links.
Yeah.
That was great.
Yeah.
That was great.
Thanks. And so I could show you.
So can you show us some of those projects you have there now?
Yes.
Physically.
Okay.
Great.
All right. So. So this is TankBot, and so I thought it would be cool to go ahead and give it lights. And in one of the videos, you can see it. I actually put 4 LEDs together, and I used a relay, that's the blue thing in the front, to be able to turn it on and off to give it the power. And so this has the 2D LiDAR, and it has, I took the camera off for now because I want to put on a RealSense camera that I have to start doing the recognition. So I started working on the software with that, using the Raspberry Pi, which is
right there.
Right there. And this is just, you know, a beehive of wires right now. But so this is the Mega. I'm not really utilizing all that much, but I had been playing. I had it put a lot of debug lights on and stuff like that, and pulled it off, and so that's doing the interface to the controller, the motor controller in the back, which you can see. Actually, those are the 2 batteries below. These are the 2 motors, DC brushless, and right in the center, green, that's the DM25. And so then this guy, yeah. So what I'm going to do is make this is kind of like its rollover cage. I put in a couple bolts on each side. I don't know if you can really see them. But, so the bolts hold this up, and I want to put a stronger round plexiglass here. And I put the GPS on top. So I have a battery on the bottom that I use primarily for the Raspberry Pi. And then I also have...
What kind do you recommend for that? What kind you recommend for the battery?
Yeah, so I use the LiPo for all of them.
Okay.
Yeah. Because they last the longest. They give you a good amperage. I had bought one really huge one. It was like 9 amps. That was a little too overkill, but who knows? I may swap out these 2 and just put one on the bottom sometime. But yeah, so you can get creative with your tie wraps and connecting down all the different PPM encoders and everything that you need to tie down your ESCs.
In the process of building this, what challenge was like the biggest one doing this? Like finding any part that you was looking for and was hard to find. What things was the biggest challenge?
The biggest challenge is, so I kind of went through this iterative plan. I actually bought this in 2 different packages. So one was like the basic frame, and it had its own different, I think it was a KK controller, which was pretty cheap. And so I wanted to know how all of this worked. And so then I was putting it on the O-scope, trying to work out issues. I wasn't exactly sure how come it wasn't getting armed, and then I found I had to go down into the right. There's a whole bunch of just learning curve things initially. I don't know if there's, and then also creating. Well, I mean they give you this little platform to give a little bounce to be able to put the PX4 or the Pixhawk on, and so that helps with vibration just in case that gives an issue. And so right now the latest thing was just getting the GPS to work, which I found last night. I was sitting out in this field at the edges field. There's a football game going on, and I had my drone out there, and then I'm like scrolling through the QGround Control and the sensors, and I finally saw the one said GPS, and I don't remember seeing it there. I remember looking for it, and it was there. And so I was reading through the different options, and there was like a mask bit, and there was also something else, and I changed that. And so instead of getting an error of that, there was no GPS fix. It was saying not enough GPS satellites. I'm like, oh, it's detecting a satellite. This is good.
So you think that's a big challenge to now for making drones like on the GPS?
Yeah, so actually in this environment is a big challenge because there's very few fields that I can get to. And a lot of times I have to sneak in because the parks are pretty much not wanting you to bring drones, or they really frown upon
restrictions.
It. Yeah, a lot of restrictions, although there's not really supposed to be. I mean, I go to these places early in the morning when there's nobody around. If there was somebody around, I wouldn't fly. And I only fly to be able to test. But, whatever. That's just the way it is. And because of these locations in Pennsylvania, there's like so many hills and stuff and trees, it's hard to get a GPS lock. And so I'm finding that to be a bit of an issue.
So for you, it's hard to make tests for the drone?
Yes. Yeah. So I'll drive like 45 minutes, and they're like, well, next time call first. And then I'm sitting out there, and it's like, well, I can't really go looking through the internet to try to figure out what kind of problem I'm having. And so then I have to head on back home. But I try a bunch of different things and kind of try to figure out what the issue is.
So at this moment, you think that is better doing tests for the AMRs than for the autonomous drones? Like it's harder, like to make tests because you're saying about the GPS and find a place that you have so many restrictions. So
yes. I didn't think it would be such a problem because I had just moved from Idaho, and it was like you just travel like a couple miles, you're out in the middle of nowhere, nobody's going to bother you. It's like lots of farmland or whatever, and it's flat. It's flat, and you can just see on and on. So there's like no problem of getting any kind of satellite.
And on the TankBot, what challenge you see like was the biggest one to build in TankBot?
So the TankBot's actually where I learned ROS. So it was learning ROS, getting up to speed on that. And then learning the LiDAR, I never worked with the LiDAR before. And then I never got a real SLAM going. I started, well, that's when I moved back here, or here to Pennsylvania. And that's what I want to go back to, is finish that and put a real SLAM system and also visual recognition, and see if I can also get a 3D LiDAR going, which probably means I'll be yanking out the Arduino and putting in a much bigger processor and battery to be able to accomplish. So it's going to be kind of a big change to it. But I love the chassis, so try to keep the chassis.
It's nice. So I would like now to take questions. I'm going to open to questions, to Q&As. Anyone that have a question for Peter, he's seen us, so we can take it. We have one here from Krishnan. I think that you saw that one before. I'm going to show it now. How to calculate the lift required after weighing all the components.
Right. So you just have to. So you need to know the weight, right, of everything, and then you need to figure out the thrust. What's the thrust range of each of the motors, and then multiply that out. And so if you have 4 motors, then you have 4 times that thrust. And it's really quite amazing what some of these small motors do. Because I was looking at, I asked the guy at CMU what kind of motors they're using, and these are like $500 motors. They're like really, you know. Of course, it's kind of like sending a rocket in outer space, right? So there's a
cheaper way to find that, or no?
I don't know. So I haven't actually gone looking, because this has been fine for this payload. Mm-hmm. So this payload has been it works. From, like I was saying, that link, I did a calculation, and I'm sure I could get the specs. I think I did at one time look at the specs of the motors also. So I kind of compared that to what this guy had done. And so you look at the specs of what the thrust of the motor is, and then what that accumulated thrust would be for that, the moment, the downward force of the whole body.
So we have another question. It was from Krishnan too. He said, "Do those motors in the robot give accurate angle control like a servo?"
Now that's a good question. I haven't been able to test it. I haven't been able to test it yet with the Raspberry Pi and the additional battery, although the additional battery for the Raspberry Pi is very small. And prior to that, it was fine. The thing would just zip around. It was fast. So there was absolutely no issue. And the Raspberry Pi and that together, I don't think it's going to be too big of a deal, but definitely I will check that out. Get back to you on that.
Oh, so we can share that information with him.
Yes, it's a costly hobby indeed. Yeah. Although, I mean, I guess I got the parts for about $500 for this. Well, no, minus $100 about for the Raspberry Pi, and then make sure you buy a lot of blades for the crashing. So they're pretty cheap, but I guess a few extra motors, and they're pretty cheap.
Yeah. So any more questions? Any more questions? Like we can take. Anybody want to say something else? Oh, there's another one. Krishnan. Can we outrun Roll Cage? Yeah, drones.
That's a great question. So that's been kicking around in my mind. How exactly am I going to do that? And so I'm sure there's Mav link commands for that, and so I'll just have to incorporate it into Mavros. But I have to research it. I haven't I haven't given it that sort of information. I mean, a lot of times the Pixhawk figures it out that, okay, well, you're going to go this speed, you're going to go, so you put in your speeds and you put in your altitudes. And so it calculates what it needs to be able to do that. But like they're doing in the DARPA, you know, that's a little bit different. I don't know how much more controlling you might have to do. I don't know. A lot of times, like you say, you give it a vector, a local vector or a global type vector, and say, you know, go here, and give it the same sort of parameters, and it may do the figuring out on its own. So, but that's definitely, I'm going to be researching soon as I get this thing automated and do something really cool. I wanted to maybe send up my other drone with a light on it and put, so I have this little Pixie cam that's able to distinguish colors. And if you put like a couple of colors together, I wanted the drone to be able to go and chase my drone. I wanted to find it in the grass, wait there, and then chase it. I don't know. That was kind of an idea.
Now we have another one from Christian. Another great question. How to synchronize 2 to 100 drones circuits in open sky?
That's a good question.
Is there a predefined software server?
I am blown away when I see that. I just, you know, like they do that at the Olympics, right? And I'm like,
at the Olympics, yeah. I think it was in.
What?
Yeah.
I don't know. That's a very good question. They must have some sort of algorithm, you know, to be able to figure out all that.
With the small ones.
Yeah.
It's so tiny.
They're so tiny.
Drones. Yeah.
Yeah, and you have to get them angled just right, and you have to get them placed just right. And it's like, well, are they cooperating with each other communication-wise, or are they just following a command that's broadcasted to all of them, and they listen to their particular? That I don't know. And that's that I really, you know, if you find out the answer, I would like to know.
What is this is a question I want to have, because you have ZenoRobotics, and you're working with all these tiny projects with the TankBot, and you want and the DARPA thing, and you're working with all this. What is the next step? Like, what you want to do in these next 2 years, and now when the pandemic and finally, and what other things you want to do with all these projects, or what is the end goal on this?
Yeah, so the end goal is to actually make some money, not just keep spending money. But no, so I want to come up with a product that's really going to be helpful. I mean, there's things like in anything that's going to be related to dealing with climate change is huge, right? I mean, we want to do things to help the climate, but we have to be putting out fires literally and detecting fires before they go off. And so that's one big mainstream that I was thinking about looking at.
There's a great use case in the fire, because there are many fires now in California.
Yeah.
See how this going.
Yeah, or even hikers that get lost. You know, can they, you know, do like a little phone video thing, and then launch a drone up, and then have it figure out where's the closest ranger station or something, where instead of trying to go find a needle in the haystack, you know, the needle comes flying at you.
Yeah, this is a great one. Like even like in the, I don't know if it can be applied, but you're like in the sea, how far it can go. So you're close, that can be used. So
yes. There's so many applications, and farming wise also.
Farming, yeah, the farming, delivery. Now Amazon and there's many companies, industries are using AMRs, and they're implementing that. Like, it's not in the full scale, but they're start to implement that. Like Amazon have one, and have a few of them, and FedEx, and they're working with that and doing the delivery of food and doing farming, like you're saying now.
Hmm. Exactly.
There's big companies working on projects like that.
Yeah.
But I think there's it's so open the possibilities that people can do with this. There's many options. Like this one this company that is using it to cut the grass. There's
Yeah.
the lawnmower AMR, and there's many possibilities
There
to
are.
work
There
with
are.
AMR.
Yeah. So I mean, right now I'm kind of open to prototyping systems, and these have been really learning platforms to get to a product. Um, and so I'm researching, and I'm researching with another individual from LinkedIn on what a good product might be from a marketing standpoint. And it's time to jump. It's definitely time to jump into it now, and also think about future pandemics, possibly climate change. Just how things need to change and how robotics can really help with that.
And I see that in your experience, you have a Lockheed Martin and
Mm-hmm.
you have MIT,
Mm-hmm.
and we see drones, automatic drones, and I'm sure that Lockheed Martin have to be working on something to use drones, and because it's something in defense that can be used,
Defense.
like yeah, it can be used, and MIT, so you know
They're
more
always
than
saying,
I mean, yeah,
yeah.
they always like in the latest technology out there. They have to be working on something like that. So now we have another question here for Christian. He said, universities to pursue MS robotics.
Yeah, so I haven't researched many. I know like CMU is like number one, but not everybody's going to get in there, and I don't think everybody needs to. Hopefully, schools are really taking their time ramping up and getting robotics. Although University of Maryland um, has a pretty good, but they're mainly software. I mean, that was another avenue I wanted to start a university where it's more like a CMU where you get more people the opportunity and not have them paying gobs and gobs of money, mainly for where they're located and what their buildings are. And I mean, like I got waitlisted for a class, and the class was like $8,500 for a semester, and they have like I don't know what 30 students. It's like what? Where's all that money coming?
Wow.
So, but anyway, yeah. So I think it. Yeah. So I don't know. I would do your research. Talk to the teachers. It depends on what you're interested in. What kind of are you interested in computer vision? Just what exactly, and then focus on the schools that mainly deal with that or who are best on that or have good teachers. So you really need to do your research. I mean, I get this question a lot, but I don't know because I'm not looking to go back to school anymore.
No, and I'm saying that there's a lot of universities out there working with things about robotics, but the best thing is going and do your own research. Like look
Yes.
on the internet, look through Google, more information, the topics that you're interested about robotics, because some universities give you like the introduction and basics, and but outside from that, like thinking out of the box is to yourself. Like if you have an idea and like, okay, I think this can work better, go and look for
Right.
information.
Yeah, look what I did. I mean,
Mhm.
this is where I've learned the mass amount of robotics. I mean, I started out looking at neurophysiology and how rodents' brains how they're able to navigate and stuff like that. And that's how I kind of got into robotics. But just in the past 2 years of building robots and trying to solve problems and getting to work and looking at things like the DARPA challenge and what that would entail, you're gonna learn what you're interested in very quickly by doing. I mean, it's usually like it's a good thing to go and work for a semester if you can as an intern or something, because even if you
Exactly.
really hate your job, well, you just found out what you don't want to do. So that's
Uh-huh.
big, you know. It's huge.
No, you take something with you, something that you learn that is have a big value in the process of working on these projects. That
Right.
you don't see it at the moment, but then later you will see like, okay, that time that I was like hating all the things I was
Yes.
doing, this is helping now, like all the knowledge that I acquired in that moment. So
So,
that's the
so
beauty of building things, that's the beauty of researching things and looking for problems that you can solve.
right.
So, and that will take you to this, like you're doing now. Like you see something, do research and start building, working on it, fixing, and like with this that we're doing now, looking for people that is talking about these subjects and topics, and then you can connect and do a network and find sources that can help you in the building things in the process. That's nice. Uh,
Okay. Thank you.
he's happy that like people is like here's like Cushman saying thanks. So
I'm actually going to step out. I appreciate that. I really appreciate that.
that's another thing. That's another subject.
Yeah, I got to get somebody. I want to get my YouTube channel of me working out, but I got to get somebody who's actually going to videotape. I just been so busy. So.
Yeah, no, yeah, but that's something that robotics don't take in already. Like, there's no robotics like doing the Mr. Olympia. So, so you find it like you don't have to worry about like when robotics start taking Mr. Olympia. Like, there's a problem there. Like, okay,
That's right. Got to lift the weights. Come on, robots.
so so thank you again
Thank you.
for this great time talking about robotics and your projects on DIY. So everyone is happy and they're glad to see all these
Yeah, get
projects.
out there and do things. You got any questions, just contact me. And yeah, send me an email and I can send you links I've been taking notes every time I run into a problem. I put a link on there and kind of say what the problem was. So there's a lot of good stuff there, and I can put it all into one file and send it to you.
Yeah, that's great. Like, yeah, all the links from Peter, we're gonna add those to the video at the bottom, or any other information you want to ask. Any other question, you can contact him, and I'm glad he's gonna be gladly to help you.
Absolutely.
So thank you again. Have a nice day. Have a nice weekend.
Yes.
So
Last weekend of summer.